Hello guys, we are the PyTorch group, and let me introduce you to our fellow members. Mioli Mark, Barshal John Poulter, and Escandor Francis Carlo. And of course, our professor, Dr. Earl Marquez Albina. In this video, we will be presenting Arduino Project 7, which is temperature alarm. The components we'll need: 1 times of DF Arduino Uno R3. This is our microcontroller, the brain of the project that reads the sensor and controls the buzzer. Next is 1 times prototype shields. This allows to easily connect and organize the components without messy wiring. Next, 5 times of jumper cables. This connects the buzzer and the temperature sensors to the Arduino pins. And 1 times buzzer. These are output device which produces sounds when the temperatures gets too high. And lastly is 1 times temperature sensor. This sensor measures the surrounding temperatures and sends the data to the Arduino. In this diagram, it shows where to put each components. Number 1, connect the BCC pin of the LM35 sensors to the 5V pin of the Arduino. And number 2, connect the GND pin of the LM35 sensors to one of the Arduino's GND pins. And number 3, connect the output pin of the LM35 sensor to analog pin A0 on the Arduino. Then connect the positive pin of the buzzer to digital pin 8. Then lastly, connect the negative pin of the buzzer to GND. Now, let's move on to the assembly of our circuit. Step 1, mounting the prototype shield. Take the prototype shield and carefully place it on top of the Arduino Uno board. The pins of the shield should light up exactly with the sockets of Arduino. Push it down gently but firmly until it sits in place. The shield works like an extension of the Arduino, and it gives us more space to connect components without directly touching the board. Step 2, connecting the temperature sensor. The LM35 sensor has 3 pins. The first pin is BCC. Connect it on the 5V pin on the Arduino. Then the second pin is Bout. Connect it on the analog pin A0. And the third pin is GND. Connect it to one of the Arduino's GND pin. And this will allow the Arduino to read the sensors output and calculate the temperature in Celsius. And step 3, connecting the buzzer. Now, connect the buzzer. Then, take 1 jumper wire and connect the positive pin of the buzzer to the digital pin 8. And take another jumper wire and connect the negative pin of the buzzer to GND. Then, step 4, connect to the laptop. Take your USB cable and connect one end to the Arduino Uno board and the other end to your laptop. This connection serves 2 important purposes. It provides powers to the Arduino so our circuit can run, and it allows us to upload our code from the Arduino IDE on the laptop to the board itself. Once the board is connected, we can open the Arduino IDE, select the correct board, and paste in our temperature alarm program and upload it. And after uploading, the Arduino will automatically start running the code. If the temperature is higher than 27 degrees Celsius, the buzzer will sound, and if it's the 27 degrees Celsius or lower, the buzzer will stay silent. Then, and here's the code. Hash include math.h includes the math library, so we can use the scene open close parenthesis function to create wave-like tones. Next is float symbol semicolon and int tone val semicolon. Unsigned long temp timer semicolon. Variables to store the scene values, buzzer frequency, and a timer for temperature updates. Pin mode open parenthesis 8, output close parenthesis semicolon. Configures pin 8 as an output to control the buzzer. Then serial that begin open parenthesis 9600 close parenthesis semicolon. Start the serial monitor at 9600 baud rate so we can see the temperature readings on the laptop. Then val equals analog read open parenthesis A0 close parenthesis semicolon. Then reads the voltage from the LM35 sensor connected to analog pin A0. Then data equals open parenthesis val times 5.0 divided 1024.0 close parenthesis times 100.0 semicolon. Converts the raw analog value into degrees Celsius. Then if open parenthesis data 27 close parenthesis if the temperature is greater than 27 degrees Celsius, the buzzer will sound. Inside the loop, scene val equals scene open parenthesis x times open parenthesis pi divide 180.0 close parenthesis semicolon. This converts degrees to radians and generates a smooth sine wave. Then tone val equals 2000 plus open parenthesis in close parenthesis then open parenthesis sine val times 1000 close parenthesis semicolon. This calculates buzzer frequency around 2000 Hz with a variation. Then tone open parenthesis 8, tone val close parenthesis semicolon. Then this outputs that sounds on pin 8. Then delay 2 adds a source delay for the frequency sweep. Then else no tone open parenthesis 8 close parenthesis semicolon. If the temperature is 27 degrees Celsius or lower, the buzzer stays silent. And if open parenthesis millis close open close parenthesis then temp timer then to 500 close parenthesis. Every half a second, update the serial monitor. And serial that print open parenthesis temperature close parenthesis semicolon and serial that print open parenthesis data close parenthesis semicolon and serial that print line open parenthesis C close parenthesis semicolon prints the temperature reading in Celsius to the serial monitor. And here is the working output of our AP7 temperature alarm. When the temperature goes about 27 degrees Celsius, the buzzer sounds an alarm, and if the temperature is lower, the buzzers turn off. At the same time, the current temperature is displayed on the serial monitor every 500 milliseconds.